Okay, number 2, we're going to do levers next, okay? So let's look at this one really fast. Okay. First of all, the most important thing on a lever is knowing what is what. Okay, where the different items are. We're going to label these very quickly because we've already gone through this in class multiple times. Okay, this longest side from the fulcrum to where you're going to put some applied force on this lever is called the length in. It's also considered the lever arm, okay, or the effort arm. Okay, all of these are synonyms of each other, but when we're looking to try to find an equation, you're going to be looking for the variables, and that's our L in. Okay, now this side over here from the fulcrum to where the load is going to be sitting over here, this is called the length out. All right, this is going to be the load. Okay, it's labeled as the load, or the force out. Okay. And then this force over here, somebody pushing down on this lever, is called the force not out. Sorry. Ooh. The force in. Okay, like that. Okay, the only thing that's different about levers and all the other simple machines is that it actually has that third variable. It has the distances. Okay, a lever has the distance that this thing moves from the ground up to however high it reaches, and this is called the distance out. Okay, D out. And over here, how far you have to push this lever down is called the distance in. Okay, and if you look on this upper side of the lever, the part that you're going to push down on, you've got length in, force in, distance in. All the ins are on this side. And this is what you do. This is what you do. You push on this side. You apply this much force. You push it for this much distance. Okay, and then all of the outs are on this side. You've got force out, length out, distance out, and this is what the machine does. The machine is going to use this length to lift this much weight, this distance. Okay? All right, let's clear this. Let's do an example problem. Say we have a lever, okay, and it has a can sitting over here on this side, and you're going to come over here and you're going to push this can up by pushing down on the lever. Okay, your hands are going to be on here. You're going to push so hard to push this lever down and lift this can up. And let's say that this can has a weight, so the force out is equal to maybe, let's go 10 newtons. Okay, 10 newtons. And let's say that you have to push down some number of newtons also. So you've got the force in is equal to some number of newtons. I'm not going to tell you how much. And then our length in is the length of the effort arm is, let's go 3 meters. Okay, and the length of our load arm is the length out, and let's say that that is 1 meter. Okay, all right. So now remember that you've got all of those different equations that you can set equal to each other. If we're living in perfect mechanical world, perfect physics world, no friction. Okay, if you are living in perfect friction-free world, you can set all of these equal to each other. IMA is equal to Fout over Fin. Okay, remember that forces are the only ones that are out over in. And then Lin over Lout. And then, let me see if I can move this. Okay. And then Din over Dow. Okay, there are more when we get into the other ones. We'll put the other ones back on again. But these are all equal to each other, not times equal. Okay. And so all I have to do is look and see which ones I have. So I'm going to write them all down in a nice little list. I'm going to say force out equals 10 newtons. Length out is equal to 1 meter. Length in is equal to 3 meters. And force in is our unknown variable. It's what we're looking for. Okay, but I've got all my variables written down. You guys, it's the thing that makes it the hardest for so many students is that you don't make a list with the variables actually identified. Use your diagram that we drew and make sure that you can identify what part of this lever you're talking about, okay? Then you just pick what ones you have. You say, I have force, I have the other force, I have length, I have another length. I'm going to grab this set and this set, and I'm going to set them equal to each other. I'm going to say force out over force in is equal to length in over length out. Okay? Now, we've got to solve it for Finn. So I am looking for this, and I'm going to circle it right here. Circle it in purple. This is what we're trying to find. Okay? To do that, we've got to get this up off the bottom. It can't be on the bottom of the fraction. It can't be on the denominator. Okay, so we're going to cross multiply. To get this guy off of the bottom, we're going to go like this and write those two down. Finn times Lin is equal to, and then I'm going to cross multiply these dudes. Okay, I'm going to go Faut times Lout. I'm running out of room. Okay, and then Finn is still not by itself, but it is at least up off the bottom. And now it's super easy to get it to be by itself because all I need to do is take Lin and divide by it so that it will cancel on this side and move over to this side. Okay, you've got to do the same on both sides. If you divide by it on one side, you've got to do it on the other side. So now I'm going to write up here the final calculation. We've got Finn all by itself is equal to Faut, which is 10, times length out, which is 1, over the length in, which is 3. Okay, so the force in will be 10 divided by 3, so about 3.33-ish newtons. Okay, and that is how you would solve that problem. Okay, now go ahead and give it a try. Practice figuring out some of these different problems. Make sure that as you practice, you're writing down your variables and writing down your equation in letters, solving it for the right variable so that it's already solved for the correct variable, and then put your numbers in. Okay, I know that when I do these examples, I talk so much, but if you're just looking at a problem that's already given to you, it takes so little time to write down everything and do the practice problem. Okay, so good luck.